हेलो। हाँ राम। हाँ हाँ बढ़िया। हाँ मैं है उठे। हैं। हाँ बढ़िया थे बढ़िया। है ना। हम्म, दाम दे रहा कल लीटर जाएंगे दोबारा। हम्म, ना। पैसा कहाँ ले तो लिए सब। हैं। और ए, जितने लिए इतने नहीं डरवा। हाँ तो थोड़े कम कम डरवा दिए। ए। हाँ देख लियो। हैं। वो कहाँ बचाओ ये गुना। हाँ हाँ बराबर। आवाज़ बढ़िया आ रही साहब। हेलो। हाँ राम राम। हाँ कछु ना हेरो बढ़िया हूँ। हाँ खा लें रोटी पानी तो खैर। हाँ हाँ बढ़िया। और का हेरो तेरो का हेरो है। हाँ बढ़िया ही चाहिए था। हाँ। कब आऊँगा था। कब आ जाऊँ। हम्म। अब बुला तू रही है तो ये खबर ना है बता। कैसे काम चले। हम्म। कैसे करेंगे। आऊँगा भाई टाइम है थोड़ा सा। बिना पैसा नहीं आऊँगा फिर जो कहेगी काय को आया बिना पैसा के पैसा। पैसा पैसा लेके ना आया हूँ। हाँ देख ले मान के एक पोतनी पैसा नहीं कमा रहे बता वहीं गए हैं। मिलेंगे पैसा भाई टाइम है तो रोज टाइम है। जब वही ना आ रहा हूँ पैसा ही लेके आऊंगा अब तो तेरे का ही। हाँ बता पैसा लेके आऊँ बिना पैसा नहीं आऊँ ये बता तू। हाँ देख ले। बिना पैसा ने मन करे ना है। हम्म। कब मिलेंगे? अभी टाइम ज़्यादा देना ना है, मिल जाएंगे। हाँ, मिल जाएंगे 2-4 महीना, 2-4 महीना तो लगेंगे अम्मा। फिर क्या लगेंगे? हम्म। हम तो पीछे करें, तो पीछे करें। हम्म। हाँ बढ़िया। खाना पीना हो गया है, रोटी सब्जी मिल जाए, दूध दूध में कर। हम्म। रोटी साग दूध दही और चावल। हम्म। दवाई तो कहीं जाऊंगा। हम्म। हैरो को छू बैठी है अभी तो। है अभी तो चल लो शरीर बढ़िया। है तुम लड़ पे निकलता। वो सब पता है, सब पता है मुझे। बस। हम्म। अम्बे। हाँ सोऊंगा अपने कल शेर में। काम करके सोऊंगा थोड़ा सा। मैं ऐसे ही सो जाऊँ 12-1 बजे। दो तो जगूँ से तो उसी फिर। हम्म। बढ़िया, ये रोटी पानी खा ली। दूध बूध पी लियो। अच्छा। अच्छा। हाँ तो फिर बढ़िया बैठी रहेगी फिर तो। 2-4 महीने। जब दूध जाके मैं तो मिल रहा तो। हाँ। हाँ तो सही जाएगा फिर तो शरीर। हाँ। अब मैं दवाई फवाई ले लेगा टाइम पे। अच्छा, ज़्यादा है जाए कबो कबो है, ज़्यादा है जाए कबो कबो। हाँ, मेरे पेपर रहो ना। यहाँ तो पर रहो तो उधर लगातार। अच्छा, यहाँ तो ऊपर रहो तो दिन, अब ऊपर ही रहो। अम्मा पे ले लिया लगा फोन। हैं? दे दो। कोटी तो फोन दूंगा अलग, जब बतरा ले करियो कोटी करी इनके फोन तक का बतरा भाई। अब इनके फोन ते इनकी कोटी बतरा वो कोई बढ़िया बात थोड़ू है। अब जाती कोटी करे भाई के फोन ते बतरा हुआ है कि कोई बढ़िया बात है का है। अलग फोन लाऊंगा तो। हाँ, देख ले। हम्म, ये फोन ले बा दूंगा तेरे का के। अपने फोने भेज दो तो अब। है क्या। कोटीन के काज का ही बतरवाएंगे फिर। अरे अपने कोटी कोई बतरा पावे तोड़ूंगा कोई। हम्म, यही वो होता है। मरन दे सब कुछ मिला। हाँ, पैसा ही लाऊंगा जब भाई बहुत लगे। हैं? मैं करवाऊंगा तो मैं क्या करूं। मैं क्या करूं फिर। हम्म, और तो नहीं। सब है क्या वो। हम्म, हाँ। हम्म, कल ले जाइए। हाँ सब कंप्लीट है। वो बैंक मैंने क्या करो तो क्यूआर कोड से करवाई थी मैंने, और डायरेक्ट बैंक के अकाउंट नंबर से करवाऊंगी। हम्म, कम है, एक ही हुआ तो मेरा शाम को। ये 3-4 घंटा तो यार दिन में, 4-5। हाँ हाँ, सब चीज़ आओ। हैं? हाँ सही चल रहा, कोई दिक्कत नहीं। रोज कोई बात हुआ है और का बात ही का है बालकन पे यहाँ। यही बात है कि क्या करना क्या ना करना, कैसे करना। हम्म, नाम तो है वो, लेकिन पूछ सको। हेलो। 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 हाँ कैसे आवाज़ ना आ रही? अरे मेरा चार्ज है। अरे वो एयरफोन एरोप्लेन पे लगाए हो मैंने, नेटवर्क वेटवर्क की दिक्कत तो नहीं होगी। हम्म, हैं? हाँ ना गई अब तो। है वो कंप्लीट आपका कोर्स का दूसरा सेशन स्टार्ट है वो? हैं? रह गए हैं वो गए, और जो ना रहे वो गए, सब गए। ज़्यादातर के यही है, कोई 20 एक बालक बचे बस। कितने 120 कितने लगभग है। हम्म। तो यहाँ तो वकीला की कहाँ पे आएगी? अच्छा अच्छा अच्छा। वो MBA हो क्लियर? MBA का। हम्म। वैसे ऑनलाइन वाली डिस्टेंस रहे, कहाँ डिस्टेंस लगने वाली वैसे कर ले। हम्म। तो फिर है, पर ये हमें तो डिग्री चाहिए, सस्ते में मिल रही होगा मुझे तो। हम्म। 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 और कौन। हम्म। और कौन। देख ले, डाल ले जो कुछ लोग। हम्म। देख ले। हम्म। देख ले डाल। सब सही चल रहा है। सब सही चल रहा है, कोई बाकी ऐसी परेशानी। हम्म। सही चल रहा है ऊपर। जब ही तो होगा। हम्म। हम्म। हाँ बढ़िया नहीं है। हाँ? हम्म। हम्म। हाँ सही है। हम्म। वो तो है ही है। ओह। मैं प्लेसमेंट ऑफिसर पे जाके मिलूंगा एक आध दिन में, बात पूछूंगा। हैं। अबे का रेट पेट ना है जो क्या वो नया आया हुआ ना, नई आई है मतलब। हाँ भाई के मारे तुम जा ही रहे हो। हैं? हम्म। मैं जा रहा हूँ तो मिलने जाऊँगा। हम्म। हैं? हम्म। हाँ हाँ। हाँ ठीक है फिर ठीक। ठीक है फिर। ऑल राइट गाइस।
So alright guys, so we left in previous stream here. Just I want this is our daily ritual now, right? So we then activate, right, like this. Activate the PIT series to require names, right? Requires names dot txt. What is our requirements? You can see this is our requirement txt. So we will write with version, right? Everything with version. Then we get add get. I think we already commented this, right? Feature is like this is our first sentiment model, right? Yeah, I think we already did that, but just two files sent, okay. Then get push new original, okay. This is our branch, right? First ML model, okay. Okay, so I think we deleted that branch, right? All right. So we don't need anything now. So now this we have our notebook, okay, which called production code, okay. Trend.py here we already have this, okay. Now in this lecture we will look into what is YAML configuration, okay, and what is logging, what is this py project .toml, what are this, okay. Like this will be used for killing the sys.path fake, okay. Yesterday what we did was huge thing, like we learned how machine actually works, learns, right? And because in that we flipped the arrow like so data plus answer is rules, right? Or we call this rules are the models, right? So this is called machine learning. This is but what is the conventional learning? Well, rule. This is for, this gives us some answer, right? This is convention learning, right? So we flipped this arrow. We understood what is back of words built by hand, okay. Then we understood gradient descent on the foggy mountain, and then we trained a real sentimental model, right? And here you can see we trained the sentimental model here. Where is the fit? Yeah. So we trained that, right? And it gave us around how much accuracy? 85 accuracy. Yeah. So let's start from today's. What is our ritual? First, git pull to in sync with the remote main, right? Already up to date we are. Okay. Now, as you see, yesterday I trained a model in a notebook, right? Like yesterday we trained a model, but this is not enough, right? To get you hired, you should be able to say this: I built a configurable and reproducible training pipeline. Okay, so this is the sentence. Like you should say, I built a configurable, okay, logged, reproducible training pipeline. Okay, this is a hire me sentence. Alright, so same model here, we are not changing the model but different engineering. Okay, so today is the difference. Here the industry secret is like roughly 2/3 of ML resumes get filtered out because they show only notebook work. Okay, no production code, no deployment story. Okay, the gap between data science and ML engineering is exactly what we crossed today. Okay, 4 upgrades is in one session. Like our training code moves into a package as a proper module. Okay, then every hard-coded number moves into a YAML configurable file. We will see it. Okay, YAML. Then print statements become professional logging, and pyproject.yml makes our package properly installable. Okay, so killing this sys.path. Okay, hack from day 3 as promised. So by end of this stream, okay, like what you will see that Python m review radar dot train. Okay, it will run the whole pipeline from config file, logs everything, and saves the versioned artifact also. Okay, that command is what a CI robot will run on day of 31. Okay, today's work is literally what makes automated ML possible later. So first concept today is this: why notebooks fails in production. Okay, this is today's class. You can do like this: a notebook is a chef tasting the spoon. Okay. Like perfect for experimenting, like test, adjust the test, right? Test again. Instant feedback you get in the notebook, right? Because you get instant outputs. But you cannot run the restaurant on testing spoons, right? Dinner service needs recipes, like written, exact, repeatable by anyone, every night identically. Okay? So notebooks are testing spoons, but production code is the recipe book. You can say like this. Like, what are the 4 problems of notebook? You can say in a very poetic way, like 4 sins of notebooks. Okay. One is hidden state. What is this hidden state? As you saw it yesterday here, like you run a cell out of order and variables become ghost from previous runs, right? You cannot run like this directly, because you need to run this to get this variable model. As you can see here, you cannot run directly this because model variable is defined here, right? So you need to run this cell first to run this, right? So you cannot run out of order cells, right? So here this is called the hidden state, right? The notebook looks correct, but while the memory disagrees here, right? In production, it's an invisible bug. You cannot see where is the problem lies, right? And next thing problem in this is it is not testable. What do you mean by that? Like, you cannot point this is which cell, 11th cell, right? So you cannot point PyTest at cell 7, right? So if you can't test anything, so there is no safety net, right? And no CI. You will learn about CI on date 11th and 12th, right? And CI is the only thing where we are going from now, okay? And this one thing. Another thing is not importable. Okay, it's not importable at all. Like our API on day 7, okay, needs to call training and prediction functions. And tomorrow we will look into the API thing. Okay, so that needs to call training and prediction function. Okay, you cannot import a notebook cleanly. Okay, and next thing is it's terrible with Git. Okay, a notebook file is a JSON soup. Okay, like mixing the code, output and images. And diffs in Git, diffs are unreadable, right? In this case, so code review becomes very hard in that scenario, right? So how professionals work out this, and you have to hear me clearly here. Notebooks are not bad at all. So what you professionals do, they explore in notebooks, right? Then refactor what works into like, okay, so you can see then refactor them into the modules whatever works. Okay, you can see like this, notebooks are like labs and packages are like the factories. Okay, yesterday was our lab experiment and today we build a factory. Okay, we will keep the notebook in the repo as documentation of the exploration. Okay, now that's because that's a true history for us. Okay, let's move next concept. What is next concept? Next concept is configuration as data. This is called the hard coding disease. Okay. In yesterday thing, you see this. What is this? N is equal to 5000, random state is 42, like this, right? And this 5000 here, and one more thing is like what max iteration 100, like this. Alright, test size is 0.2, like this. Okay, they are all in code. You, if you want to configure them, you have to find it like, okay, where is this, where is that, right? That's very complex. If you want to try 10,000 features, you have to edit the code. Every experiment like mutate the source code, right? And which code version produce which result, nobody knows that, right? It's a chaos all over. To fix this, one of the oldest and deepest principle in software is like this. What we have to do, we have to separate the code configuration. Okay, so from now on, code for us will be the logic. Okay, like how things happen in this, and config for us will be the choices. Alright, like which value to use and all, because our logic changes very rarely, and configuration choices to experiment things, they changes constantly, right? So to config our project, we will use this YAML. Okay, so it's a human friendly format for structured setting. And why we are using YAML, not the JSON? Because YAML allows us the comments. Okay, like needs no quote and braces ceremony, and it's like it's very popular in the infrastructure world. Okay, Docker Compose, we will understand this on day 10, and GitHub Actions, Kubernetes. Okay, all of these are YAML configurable. Okay, so learning it today will pay for the next 39 days for us. Okay, so this is example of a YAML file like this. How this YAML file looks. We will have this S you can comment like this. Okay, like Python, it will be like this. T is value, okay, and number is 55,000, okay, and nested will be like so you can comment here like this. By has, what is this? It's nesting via indentation. Okay, like Python, and these numbers are like these are auto detected. Okay, and for string there is no code needed. Okay, in YAML no codes needed. Alright, and you can see if you want to define a list, then you can go list, and you have to use this dashes here. Okay, first, second, like this. Okay, so ML flow for us will log the config of every training run automatically. Okay, so config driven code is what makes experiments traceable. We are laying Mlops rails right now. Okay, and the next concept for us is this logging. What is logging, guys? Logging is like this. It's our print's grown up version. Okay, grown up sibling, you can say. So print is like shouting into the room, right? It's fine, it prints everything when you are alone at your laptop. Okay, and logging is a SIPS logbook, like every entry stamped with time and severity, okay, written to a permanent record, and it will be readable long after the voyage. Okay, in production nobody is watching the terminal. Something breaks at 3 a.m. so the logs are your only witness there, right? So the severity level. Okay, let me introduce this thing. The severity levels. Okay, what is this? This is one thing is debug. Okay, debug is like it's a microscopic scope detail. Microscope detail. What do you mean by that? I mean by that is like vectorize, built, right? Vocab size is 5000, like this. Okay, and what is info? Next thing is info, right? It's like a normal milestone. Okay, like if training is started, like this, like training started, these are all milestones, right? Or like when model is saved, so like this is the info level of severity, right? Then we have warning, like this. Some things are suspicious, right? But they are alive, right? Like you can warn about, okay, there is only 900 rows and expected 5000 of samples, right? Like this. But it will work, but there is a warning, right? Then we have error. Okay, like it will be triggered when something failed, right? Something has failed, right? could not read data file. Like this. So if you cannot read, then how can you train the model? So it's an error, right? And something is critical, like it's very critical, like ship is sinking for us, right? Everything like went filled. The superpower, the print, which is print can never have, is like that you set a level. Okay, so because productions run at info, quite. If something is wrong, flip to debug. Okay, the microscope switches on, right? No code changes. Okay, on the day 23, these same logs ship into Loki and become searchable across every container in our cluster. Okay, so we will build a habit from today. Okay, whatever it is, we will build the habit. And next concept, guys, is for us pyproject.toml, right? Like it's like making our project real. So you remember day 3 what we did? We did this sys.path.insert, right? We did this insert 0, src. What did it mean? In main.py, right? And I promised that day that we will fix that. So problem was that our Python doesn't know our package lives where, right? So we have to tell, our the packages live here on src path, right? In src. Okay. So this tells one file about it. The real solution is will be for us, like what we will do. We will install our own packages into the venv. Okay. So this is the final solution for that, right? Like pandas or sklearn. Then every file in every notebook and every test can import our reviewed radar from anywhere, right? So that's why we need this. So this pyproject.toml is a modern standard like this, PEP 621. This is a standard. One file describing the project, right? Name, version, dependencies, where the code lives, everything. Okay. It replaces the older setup.py. You will still see in the tutorial. Okay. And the magic trick is editable install. PIP install this PIP install this. Okay. So the E links, right? The E links the installed package to our source files. Okay, instead of copying them. So we don't need to copy that also. So if you edit the code, okay, changes are live instantly. So no reinstall, right? It's how every professional Python developer works on their own package. Okay. So pip install E is like link the mode install package to the source files. Okay. As you can see, main.py, what we are doing here, right? Sys.path insert like this we did. now we know from review radar import this, right? We need to tell that, right? Okay, you have to point here, and you can like look in this review source review radar, and these were our modules, right? So that's what I was talking about, and next is this. So you some questions you can face is like, okay, how do you move from notebook experimentation to production? You can face this question, right? So your answer should be this: refactor. Refactor the working notebook code into a tested package modules. Okay, notebook to modules, right? With the config driven parameters. You know config is it's just config is like we will separate the code and the choices, right? Which values to use. So in to configuration we use a YAML. It's a very human friendly structure, right? Now and we use logging also, and we will keep the notebook as an exploration record, right? Exactly today's session you will answer from experience of that. We will look into it, and also you can face an question like this: why separate configuration from code, right? Right. So your answer should be like, we can experiment without the code edits, right? Experiment in the notebook, in the configure file, right? YAML file. We don't edit the code and change the version of code every time. We just change the variables and choices in the configuration file, like n is equal to 5,000, 10,000, whatever local size we want, and this random state and everything, right? Trackability and no secret in sources, right? So secret file like what on what factor, when what is random state, what is the vocabulary, we can keep our secret in configuration file, right? And you can face this question, okay, what is logging and what versus print? So in logging we can decide labels, right? Timestamps, output routing, like console file aggregator, like this, okay? And it's global verbosity control without code changes. We will look into it what it is. And you can face this question like, what is an editable install? Editable install is like this: when you install a package, and that package will link and point to the source files, and if you edit the source file, then you don't need to reinstall that, right? So it will as I told you here, pip install e here, this is the editable install, okay? It will link the site package to your source tree, so edit applies immediately, right? So it's very standard when you develop your own packages, okay? So let's come to the very practical things now, okay? And we will create our new branch. Git switch C, this is for create if there is no branch, right? Features less production, right? Training, okay? So let's do a new branch like this. If we want to give status on branch this, right? Nothing to commit, working clean. Okay, and we will make a directory, make directory like configs. Okay, you can see there is a directory here, configs, and we have to create a config file also. Okay, you can see like this here. What we will do, because we are creating a YML file for training, where it is first for this, right? What is the name of this? First model IPYNB, right? So let me create a file like touch configs / train.yml. okay, so this is our YML file. If you are wondering, a full form for this YML is so you know YML stands for YML and markup language, like this. It's a recursive acronym, meaning the acronym itself is used inside its own definition. So yet another markup language is YML, but the creators later changed it to emphasize its focus on data rather than document markup. Okay. So YML is, like you can say, yet another markup language, but it's not like that. Okay. It's not like HTML and XML. Okay, it's like you can say YML exactly stands for like Y stands for YML and AML stands for Ant markup language. So you can see Y stands for YML and A stands for R not, M stands for markup, and L stands for language. So YML means YML is not, aren't another markup language. Okay, like this. Alright, so that's so we have this, right? So let's try to write something in this file. Okay, so we are configuring for review radar sentimental model, right? So we will change values here and will for now, and we will never change those in code. So every experiment new values, but the code will be same. Okay, so let me do this. data, indentation is used, right, like Python here. So data set name is IMDb. Okay, so it's a Hugging Face data set ID. Okay, and we will have sample size here is 5000, right, and test size is 0.2, right, and random state is like state is 42, like you know what is random state is for reproducibility of seed, right, same random state then same output every time. This test size is like fraction of data locked away, right, from the training. Sample size, number of rows to how many rows we use. Okay, and next thing is we will have features. Okay, indentation, max, features is 5000, like it's vocabulary code for us, like for TF IDF model or vector embedding model, you can say bag of words, right. TF what? Inverse frequency, true frequency, and inverse document frequency, like this. Okay, and n-gram range, we will test this today, 1,2. Okay, as I gave you it as homework, right. Stop words, like it should be English, right, English. Also you can comment these things, like okay, here this is the advantage of this, other than JSON, right. Right. And what is n-gram here, if you want to understand, is this one word and word features, right, and this is for vocabulary for TF IDF, right. That was it, and this was next features. And for model, right, for model you have this max iterations, right, or 1000 here, then random state is 42, and for output you have this model directory is models, right, like where artifacts lands, right. So you see every number from the notebook is extracted into one readable file here, right. You can see here. Okay. So So when we use this config file, right, because this configs, okay, it will hold one YML per file per pipeline. Okay, we will add more YML files on next days when we do orchestration, configuration and all. Okay. Okay, so what we do in source, we will create one more file. Okay, one more file here will be like this. Okay, source slash review dark slash trend.py. Okay, we have this file here. What we will do, we will build this function by function. Okay, we will wire everything and we will not run it until everything is wired. Okay, so what this file is about? Okay, so it's a production training pipeline. Okay, right, it's a production training pipeline here for review radar, right, sentiment model, right, and now what is this? What we are doing here, we are refactored from notebooks slash 01 right. Well, first model dot ipynb, right. This was the file. This was the file here. First model ipynb here, right. That's what we are doing. And after that, run python and review radar dot trend. Okay, so that is config slash trend dot config. Okay, dot YAML. Right, so that's for introduction of this file. What we do first, we will import argparse. What is this? It's a standard library for command line arguments. Okay, like how we will accept dash config. Okay, so we are accepting this dash config, right? How we will accept this? So this is for standard library for command line arguments. Okay, we are using this because in production scripts, okay, production scripts take the parameters from the command line. Okay, not from the edited sources. Okay, that's why we need to give them to in the command line. Okay, one by one. Then import logging. So it's the logbook for theory. Okay, from the theory we discussed, and from path lib import path. We already know that why we are using this path lib.path, and import job lib is for artifacts, right. import pandas hpd whatever. Import one could not result source. Okay. Okay, why not? We will see everything. Okay. And next thing we will import is import YAML. Okay. So there is a thing py.yml. It will read our config file. We will install it in a moment. Okay. Now from data sets, import load dataset. Okay, we have that. Everything is not configurable here because we will do this. Okay, in the configuration. And from sklearn dot feature extraction dot text. Okay, we will import this tfidf vectorizer, right? And from sklearn dot linear model, we will import this logistic regression, right? Regression. And from sklearn, right? From sklearn dot matrix, right? Import accuracy scores, average score, comma, like this, right? And from sklearn dot model selection, import train text split, right? Okay. And now next thing is logger equal to, we imported logging, right? Logging dot get logger name. Okay, so this will create a modules name logger dot name is equal to review radar dot train. Okay, so this one line will carry its origin, means like where this log is coming from. Okay, so one logger per module we will have one module and one logger for it. Okay, and always this exact line. So we have this trend.py in review radar.trend.py, right? So this name is like exactly this. Okay, it will automatically assign this. Okay, now def load config. Okay, config path, it will be a string format, right? And it will return a dictionary. Okay, so what is this? So we are using this to read the YML file into a nested Python dictionary. Okay, let's see what happens. So how we read a file? So with open, right? Open is from the config file we will open the file. Okay, as f we open the file, and config is equal to YAML not safe load f. What is doing? So this safe load function of YAML, it parses the YAML file. Okay, and safe, why we are using safe here? Like it's using, like it will refuse to execute any arbitrary object. Okay, if you do YAML dot load unsafe, so it can run code hidden in a YAML file. Okay, so like it will be a real attack for vector for you. Okay, so always use safe load. It's a small habit but real security threat. Okay, now after you load this file, open this file and load parse it in safely, right? Now what you will do, you do this logger dot info. You are setting a label, right, at info label. What is info label? When you do this info label, when some normal milestones achieved, right? So there one milestone achieved, like you loaded a config file, right? Config from config path, right? You loaded it. Now, and what you will do? You will return config. Okay. So you are returning a dictionary here, right? Okay. You can see here. Now you return the config. Next function for us will be this def load data. Okay, so data is config is your dictionary, right? And what you will return from here, pd dot data frame, right? You will return data frame here. All right. now so what we are doing here in this function, what we will do, you see this notebook and you see the cell one here. Okay, what we did, we load the data right from the data set. Okay, so one more thing, in config file we missed is like we have to write this completely. Okay, so as you can see in our train.yml and data thing, we have to do this completely. Okay, all right, so we will do that thing here again. Okay. Data config is equal to we have this config dictionary from here, in dictionary we access the element of dictionary, right, key value 4. Okay, and logo.info you can see for loading data set, right, and CFG, right, in this data CFG what you are doing, you have what is this key values, right, key and value. So what you will do, you will in data CFG you will access this. Okay, data set name. Okay, you have the data set name here, train.yml data set name, right? So that's why you are data set name. Okay, data CFG is there, config. All right, so can you directly do this? No. Yeah, you have to do this like that, and you can do it like this only. Okay, like this, and you log the information, and then after that you are you get the data set. Okay, data set is equal to load data set, because you already imported this function, right? Here, load data set module here, right? Where it is? Load data set, right? So data set is load data set. This is Python thing, and data CFG, right, and data set name. Okay, whatever it is, you have to import it and split, right, is equal to train. this was the real function here also, right? You can see in the function split a string, and we are giving this argument in this case load data set. There is nothing new, right? Here we are just we have a data config dictionary here, and we are accessing the name from there, and we are loading it, right? There is nothing very complex, okay? And then after that we will convert it in data frame, period dot data frame, right? You are converting this data set to data frame dot sample. Again, what you will do for sample, n is equal to data config, right? CFG, right? You say sample size from here, right? Sample size, then you should have this random state is equal to data CFG, right? You would say random state, which is already there, right? You can see here in this file random n is 5000, random is 42. So what you do here is you write test size you configured, sample size you configured, everything about data, right? So you can change these here. So that's how it will work. Okay. Then after doing this, what you will do? You logged, and the log.info, you can info about this, right? Like loaded plan of df, right? Rows, right? Label balance is this like this. You can see like data frame label, right? Dot value counts, right? Like this. You can use this function. It will check the balance from day 5 is we already did there. Okay. And after this, whatever that, because we have to return the data frame here as promised df, right? Now from here, what we will do is def split, okay, split data. Again, what it will do, it will take this data frame, data, or you can say and it will do the config as of dictionary type, okay, and we will split the data here also, like data CFG is equal to config data, right? We are accessing the dictionary. In the dictionary we have key value, so accept rank comma x test comma y test, that we are splitting the data, and trend test split, what we will do, text, okay, text, this is our x thing, and df label, this is our value, okay, then text size will be able like this. Data config, text size, right here, and after that what we will have is state will be also data config, random state, right? You can see here, and statify is equal to df label. Okay, we have done this, and after this we will log the information like this, log.info, split, then extend, right, hash train, and then of text as text, right? We splitted it like this, and after this we can return string from xtext from white train from white text. Okay, after this what we will do, we will do the vectorizer. Okay, this will be vectorizer, it's ready. Okay, tf idf, run it, tf idf vectorizer. Okay, we have to record this. So what we will do here is we will construct the tf idf machine from config. Okay, how we will do that, let me tell you. Create config. Okay, config, we are taking this features. Okay, how many, what is the vocabulary size and everything. Okay, and after this we can return from here only. Okay, so we are returning this tf idf vectorizer, and this is like we are able to find max features, feed cfg, right? We have this max features variable here, right? And after that we will n-gram range also, we can arrange that also here. Okay, it will be our tuple. Okay, of this feed config, n-gram range, as you can see here. In the YML file, n-gram range is there, right? So that's what it is. Next feature, and stopwords also, we have to take this. Okay, because YML list arrives as a Python list here, so we typecast it as a tuple. tuple tuple, right? But sklearn wants a tuple here, right? So what we do, tuple converts list converts to tuple. Okay, and also one more thing we need to do is stop words, is like feed config, right? Stop words, you can see how we accessing dictionary from the in Python, right? Like key values, like arrays only. right? And yeah, that's it. So that's it how we build the vectorizer here. Okay, now what we will do, define a function called train and evaluate. Okay, what it will take, it will take xtrain, okay, xtest, ytrain, ytest, okay, and one more thing it will should take is config of dictionary type. Okay, now so let's define a vectorizer here. Okay, vectorizer equal to build vectorizer. Okay, and we are passing a config file only, right? And here, because we are accepting a config file here, so we are passing is when we can log is like logger dot info label, right? Logger dot info, because we are using the info label, and you can comment it like, okay, vectorizing, okay, so fit on rank transform on test, okay, no leakage, okay. So what we will do, we have our xtrain, we have data frame, right? So we will convert into vectorizer, the vector, okay, back of words vector, okay, xtrain vec is equal to vectorizer dot fit transform, okay, because it's a training, right? So we are just fixed transform is like we are finding the meaning right here first, okay. So we are xtrain, we are giving this value, and xtest vec is a vectorizer dot fit. We are not using transformer here, okay, because we can say we are just using transform, okay, xtest, because on day 5 and yesterday the most important rule was this okay. Now next thing is for us will be model cfg is equal to config models, or you can say model here, whatever it is there, model equal to logistic regression, right? We have a model where the logistic regression has a function, the activation function, right? Max iteration is like we have our model config, right? Max iteration is there defined like this, right? And random state also defined there. Model CFG for and state, alright, like this, and Yeah, this is model is configured here. How many stations it will go, and what is the random state for this. Okay, it's using a logistic regression as activation function. Now what we'll do, we can log this also, milestone log dot info only, right? Training model, right, like this. And how you train this model dot fit, and what you provide in this model, the x test train vector, right, comma y train. You have to provide the output also, right? And y prediction is model dot predict on x test vector. Okay, so on this vector it will try to predict, and whatever it predict, what we can do this with that is we will calculate the matrices, right? Matrix is equal to this will be our dictionary, I think, accuracy. Okay, round. Okay, round like accuracy score, y test what we have, and y predict, right? We have this, and till for like this. After this we will have our F1 score also, right? Round F1 score, y test, y predict, right, comma 4. Alright, so that's it. Now after this, what we can do here is robot.info, like matrices are there, we can print the matrices, right? And then we can return the model and vectorizer and matrices, okay, from here. And now we will define functions to save artifacts, right? Artifacts. Okay. It will take the model and it will take the vectorizer, because vectorizer is very important when we are matrix. Okay. And we will also have the config file. Alright. So it is for to purchase the train pair. Okay, train pair is like model plus vectorizer and a matrix record. Okay, so we can save this. Okay, like this. Model directory is this. Path config output. Okay. And in this output, what we can config, model directory, okay, we can configure like this. Also you can see in the YML file, in the model, in the output we have model directory, right? so which is models. So we can change this directory anytime. So you can see here model directory is not right. Okay, and after that we will have this model directory dot make directory, and you can exist okay is true. Okay, if it already exists, then don't give error. That's why we are using this. And to save this, job lib dot dump. Okay, model, we are saving this model, and model directory, right, slash what will be the file name, slash sentiment model. Okay, or job lib, and then model job lib dot dump, right, and we have vectorizer here, model directory slash vectorizer, right, dot job lib. Okay, so this is a path object. It will join with this. This will join this. Okay. So we are saving this model plus vectorizer together, and we have to always do this. Like it's like a lock and key. I explained you yesterday. Okay. And then after this, what we will do is you will open a file which is model directory slash matrix.yml. Okay, and we will use open it in a write mode as f, and what we will do, yml.dump matrix f. So what it will do, it will write matrix as yml. Okay, next to the model. So it will be an artifact, should carry like its report card of the model. Okay, so now, so we are what we are doing is we are creating a file in writing mode, which is matrix.yml, which does not exist right now, but it will be created, and we will use this matrix. Okay, in this file f, and we will store that as yml. Okay, after this what we will do, we log the info. Okay, artifacts saved to model directory, right, slash, you can say like this. Now next thing is we have to run the training also, right? So def run training, we will have the config path also, str. Okay, and return the dictionary. So it will be our whole pipeline here, and it will chain every step. Okay, this exit function gets called by test on day 11 and CI on the 31 and everything. Okay, so let's do this. Config equal to load config, right? You can see config path we have. We will load this file, okay, by this method. Where is the load config method? Load config is here, right? So which is will give us the in dictionary format, okay. And after loading this, what we will do, we have is equal to load data also. We have to pass the config also in this, okay. We will get the data frame, and we get this extend, okay, extract y train y test everything, right? From the split data, right? df we have to give the data frame and config, right? And after this we will so model from vectorizer we will get the matrices, okay, is equal to from the train and evaluate function, right? We pass this x test from x train, okay. Then we have x test, then we have y train, then we have y test, and we have config also, right? Then we call this model save artifacts, right? And this model from matrix, right? Okay, we have to do vectorizer, right? Then we have this matrix, then config, right? And after that we have this logo.info, like training pipeline complete, right? We can log like this, okay. What happened here? Okay, and after this we can return matrix. Now comes the main function, okay. Def main function, in this logging dot basic config, okay, label is equal to logging dot info, okay, and format is equal to like this. We have to define the format of %ASC time, okay. Then names of the source, right? Then label names, right? And after that message, okay. So every log line is like timestamp, then module, then severity of that, and the message after that, right? That's why basic config lives only here in the entry point, okay. Modules create loggers, and the app decide format and label, okay. So cardinal rule by Python logging, it is a rule, and after that we have parser is equal to arg parse dot argument parser. Okay, we have to get this. Description is equal to, you can give anything like train the review radar sent treatment model, right, like this, and parser dot add argument. You can do this config default is like this, config slash train dot yml. Okay, okay, help and help is equal to this, path to training config yml. Okay, it will define the config flag with a sensible default here because we are there, and after that what we will do is and different config is equal to different experiment and same code. And next thing is args equal to parcel dot parse args. Okay, run training as args dot config, we can pass, okay, like this, if name equal to man, right, then only call man. And you can compare mentally with the notebook here, same ML is here, completely different engineering, but okay. So what we will do, first we will install the YML support first, right, train.py imports, we will import it. So what we will do, just pip install pyyml. First we have to do this, requirements already set by py, okay, it's already there, okay, then pip freeze, okay, requirements txt, okay, it's already there, then requirements txt there, then next thing we have to thank you guys. From now we will do tomorrow, okay, we will continue tomorrow. Thank you so much. Okay.